Measures of central tendency are used to tell approximately where our data values congregate. In other words, are our data values more near 1,000? Are they near 500? Are they near 5? Measures of dispersion have to do with how spread out or varied your data values are. We're going to start by just getting familiar with a little notation so that we'll be able to read formulas for statistical and numerical quantities. And we're going to start with summation notation. And it's a compact way to add up a series of numbers. This is the Greek letter sigma, capital, and often we use that to indicate sum, S for sum. This I is what we call an index variable and is used for the purposes of counting your data points. Okay, so let's look at this one. Here's some numbers: 8, 2, 6, 10, 4, 9. We want to find the sum from I equals 1 to 6 of x subscript I squared. All this means is that we have 6 numbers. xi is the ith number, so this is going to be x1 squared. x1 just means the first number. x2 means the second number, so we're going to take that and square it. x3 is the third number, and we're going to square it. And a lot of times we'll use a dot, dot, dot to indicate that our pattern continues, but then we want to make sure we put the last one in the series. We have 6, so x6, that means the 6th data point. And we're going to square them all. So here we're going to have 8 squared plus 2 squared plus 6 squared plus 10 squared, 4 squared, and 9 squared. And if you add all these up, you should find that you get a total of 301. So that's all we mean by that summation notation. Let's move on. We're going to talk about the mean, and you've heard of this before. You may have learned it as far back as elementary school. You probably called it the average. When you have ungrouped data, meaning we have the actual raw data, we have a list of numbers, the mean, or the average, is equal to the sum of all the data values divided by the total number of them. In other words, add all the numbers up, divide by the number that you have. A little notation. We're going to use an X with a bar over it to indicate the mean. If we have a data set that's a sample of a larger population, we're going to use the Greek letter mu if we are looking at the entire population and not some sample of it. So we're going to assume you already know how to do that, and we're going to move on to determining the average for grouped data. And there's a formula here, which I think will make more sense after we do the example. This has to do with finding the average or mean of data values when all we have is a frequency table. In other words, we have a list of intervals or class intervals, and we know how many data values fall into each, but we don't know the exact original data values. This formula is equivalent to the one above that you've known for a long time that says that to get the mean, we add up all the numbers and divide by the number of data points. That's still going to apply. Let's do the example. Let's find the mean for this set of grouped data. So what we're going to do is we're going to add a column to this table, and we're going to use it, we're going to call that column XI for the midpoints. So what we need to do is we need to determine what value is halfway in between 1.5, and 4.5. And one way to do that is to average them. Take the lower edge, 1.5, and add the upper edge, 4.5. That adds up to 6. We're going to divide by 2, so we're adding the lower and upper edge. We're dividing by 2, which means we're averaging them, and that'll get us the number that's halfway in between. So this gives me 6 over 2, which is 3. Let's look at the next one. If I do 4.5 and add 7.5, that gives me 12. We're going to divide by 2 because I'm averaging two things. And so I end up with 6. So I'm going to add that to my extra column. And if you think about those numbers that we have, if I just asked you what was halfway in between 4.5 and 7.5, well, we would say 6, because 6 is 1.5 units from each edge of that interval. Now you ask yourself, what is halfway in between 7.5 and 10.5? If we look at 9, that is going to be 1.5 units from each edge. And then here, 12 will be 1.5 units from each edge. As long as your intervals are all the same width, your midpoints should all be the same distance apart. In other words, my intervals, each of my intervals are 3 units wide. So how far up do my midpoints go each time? 3. They jump by 3. 3 to 6 to 9 to 12. Okay. So we're going to assume this is a sample. Which tells us that we are going to use the X with the bar on it for our notation. So we do not know exactly where these 3 data points are that are in this first category if we look at these first. We just know they're somewhere in between 1.5 and 4.5. We don't know where they are. What we're going to do is we are going to assume that they occur at the midpoint. There's no reason to choose the high edge or the low edge, so we're going to choose the midpoint, which is halfway through the interval. And we have, our midpoint is 3, and we have 3 of them. So I would end up with X bar. I have 3, and I would have 3 of them, so I would add the 3 together. Let's need a plus sign in there. Then we would move to our next category. Here we have 4 data points. We're going to assume they are all actually at the midpoint, which is 6. So we're going to put 6 in, but we're going to have to put it in 4 times. In other words, we have 4 of these. We have 3 of these. And then the next entry is 9. We're going to assume they're all at the midpoint, and there's 7 of them. So if I were to write this down 7 times, 1, 2, 3, 4, 5, need 2 more, 6, 7, is that right? 1, 2, 3, 4, 5, 6, 7, yep, 7 of those. And then there's last 2 data points I will assume occur at 12. Now, how many data points do I have altogether? Well, I've got 3 here, I've got 4 of these, that's 7. Here's another 7 of these, that's 14, 15, 16. I've got 16 of them. Now, you wouldn't want to write all this out if you had, say, 50 data points in your interval. There has to be a better way, and there is. If you notice, multiplication is just repeated addition. So if I add up 9 and I add it up 7 times, what is that? 7 times 9. So I can write this all as multiplication. So I'm going to have 3 times 3. I'm going to have 4 times 6 because I have 4 6s. I'm going to have 7 times 9, and I'm going to have 2 times 12. And I'm going to assume that's assuming that all of my data points occur at the midpoints. Now how many data points do I have? 16. This is the way you would normally do it. You're not going to write this long way out each time, but it helps you to remember the formula. How could I have gotten the 16? Just add the frequencies. If I come back up to my table, 7 plus 7 is 2. That looks like 16. Okay, so that gives you your denominator. So add all these up, you'll get 120, which we're going to divide by 16, which is 7.5. That is our mean. If you'll flip back to the formula now, let's see if that makes sense. Here is our formula for grouped data. Notice, what does it say? It says take the midpoint and we're going to multiply it by the frequency. And then we're going to divide by the total number of measurements. And to get this, what do? We add the frequencies. Let's move on. The median. Sometimes the mean can be misleading for a data set. If we have a math class, and let's suppose we have 7 students and they have test scores out of 100, 88, 99, 7, 78, 89, 94, 76, as you see here. To get the mean, and here I'll use mu because this is the entire population of this math class. Not this math class as in the one that you're in, but this math class as in this particular example. So we add all this up, divide by the number of measurements. How many are there? 1, 2, 3, 4, 5, 6, 7. There are 7. And so this ends up being about a 75.86. Now, if you'll notice, how many students fall below that average? Only 1. And that would be the student that has a 7. And so that 75.86 is a little bit misleading because really the class is better than that as a group, as a whole. In other words, nearly all the students are better than that, or at least they scored higher than that on this particular test. So a lot of times the mean is not the best indicator of where a group of data values falls. Let's look at something else. We're going to look at something called the median. The median is essentially the middle or center of the data set. It's going to be the middle measurement. We want half the data points will fall above the median, the other half will fall below the median. So if we look at that particular group of test scores, what we're going to do is we're going to sort them in order. So the 7's the lowest one, then the 76, 78, we jump to 88, 89, 94, and 99. We've got 7 of them. This is the middle of the data set because there are 3 on either side. So our median is equal to 88. If you've ever looked into purchasing a house, you'll notice if you look up subdivisions in the newspaper, it doesn't give the mean sales price in a neighborhood. It gives the median. And the reason for that is that the median is unaffected by extreme values. In other words, if you have a millionaire building a giant mansion on the corner of a suburban block, it certainly would raise the average home price in the neighborhood if you were going to calculate the mean. But as far as calculating the median goes, it's simply one more data point. It won't drag your average up. And similarly, if you have a falling down house on the corner that has a lot of problems and isn't worth very much, it won't drag down the median price in the neighborhood very much. Okay. The mode is the most frequently occurring data set. So sometimes you'll have a unique mode. If you have one data value that's the most common, sometimes you'll have several modes, sometimes you'll have no mode. Let's look at this. Let's find the median and the mode for these data sets. And one thing that's helpful when you're trying the median, if you have them listed in numerical order here, they're already listed that way. But if you list them that way yourself, you can do this too. If you have a bunch of them and you're trying to find the middle, you can count how many you have, divide by 2, and that'll tell you about how many you need to move over to get to the middle. But you could also cross them off from each side. I'm going to cross off one on that edge, one on that edge. And if you get just one data point in this middle, that's our median. So here, our median is 5. Okay, our mode is also 5 because that's the most frequently occurring measurement. Okay, because I have 3 5s. Actually, I have 4 5s. Let's erase my mark so I can see how many 5s I have. Yes, we have 4 5s. Alright, let's look at the next one. What's the most frequently occurring measurement here? We have, there's a tie. We have 3 of these, but we also have 3 7s. And so we sometimes will call this bimodal data because there are 2 modes. Our median, okay, let's mark them off from the edges like I did before. This time I'll try not to cross them off so that we can still read them afterward. But if I mark the ones on the ends. Okay, now I get 2 left in the middle. If you have 2 left in the middle, you're going to average them. In other words, if you have an even number of data points, what you're going to do is you're going to find the middle 2 and take the mean of those, and that will be your median. So to take the mean, I add the 2 together, divide by 2, so it's 8 over 2, which is 4. Let's look at one more. Do we have any measurement that is, okay, in this data set, we have no modes because no measurement is more frequent than any other measurement. If we look at the median, once again, how many data points do we have? 1, 2, 3, 4, 5, 6, 7, 8. We have 8 data points, so we are going to average the 2 in the middle. These are the middle 2. We have 3 on either side. So my median will be, add those 2 up, 6 plus 7 divided by 2, or just think to yourself, it's going to be halfway in between 6 and 7. What will it be? 6.5. That's how we find median and mode. Hope